In this video, we're going to discover the Bellman equations, which will be of vital importance when searching for the optimal policy to solve control tasks. This one here is the Bellman equation for the value of a state. Starting from the definition of the value of a state, which we know is the expected return following the policy pi from this state, we can expand the definition of the return to arrive at the second expression. If you notice, this expression, starting at the second term, is equal to the return starting from the next moment in time, discounted by gamma. And thus we arrive at the third formula. Finally, to get to the fourth expression, remember that the value of a state is the expected return. This mathematical expectation can be written as the probability of taking each action following that policy multiplied by the return we expect to get from taking that action. And that return can be expressed as the probability of reaching each possible successor state multiplied by the reward obtained upon reaching that state plus the discounted value of that state. Notice that we have discovered a recursive relationship between the value of one state and the values of other states. This will be very useful in the next section for developing algorithms capable of solving control tasks. The same process can be followed for the Q values. Starting from its definition, that is the expected return from taking action A and then following policy pi, we can expand the definition of the return to arrive at the second formula. Then we can transform all these terms into the discounted return starting in the next moment in time, as we did for the values of the states. And we can arrive at this expression. Finally, we can rewrite the expected return as the probability of reaching each successor state, knowing that we have chosen action A, multiplied by the first reward obtained upon reaching that successor state, plus the discounted sum of the Q values of each action in the successor state, weighted by the probability of choosing that action by the policy. In this way, we have managed to express a Q value in terms of other Q values. These recursive relationships will be used to develop methods that will solve control tasks.